Hi and welcome to another Forest Service web tutorial. My name is Mariana Dobre and I'm a research scientist at University of Idaho, working on the development side of WEPPcloud. In this video, we'll learn how to select climates. In WEPPcloud, you have several options to build the climate files. These options are a combination of both observed and stochastically generated data. To run the model with long-term continuous simulation, we need information on several daily weather parameters, such as precipitation amount, storm duration, time to peak intensity, maximum rain intensity, minimum and maximum temperature, solar radiation, wind speed and direction, and the dew point temperature. All these weather parameters are generated with the CLIGEN model, which is a stochastic weather generator based on the data derived from 40 years of recent climate records between 1974 and 2013 in the US. I will add a link in the description to a manuscript that better describes the CLIGEN model and the recent climate records using the model. The first option on the interface is to select a weather station that better describes the weather within your watershed. And here you have two options: either to select the closest climate station to the outlet of your watershed, or to select a station based on the multi-factor ranking, which besides distance also considers the elevation at the weather station. This step is quite important because the interface is using the station to stochastically generate typical rainstorm amounts, duration, and characteristics. For example, by selecting the closest station, we select the Silver Creek Falls, which receives on average 1,400 millimeters of annual precipitation. If we select the multi-ranking option, then we select the Marion Forks station, which receives 400 millimeters or more of precipitation. For runoff and erosion, 400 millimeters of extra precipitation is quite high, but we also need to consider the differences in storm intensity and duration, which can also be different from station to station. So you really have to be careful with the station you are selecting to represent the climate of your area. You can also select other weather stations based on the drop-down menu. Since I don't have other information on this watershed or the weather data, I will go ahead and select the closest station to the outlet of my watershed. Next, you need to select a climate method. The first option, Vanilla CLIGEN, will generate one stochastic weather file based on the data recorded at the Silver Creek Falls. The Prism modified option will alter the precipitation and the minimum and maximum temperatures based on monthly and annually Prism maps. These are gridded maps of interpolated precipitation, Tmax and Tmin, from a wide range of monitoring weather networks available for the entire US. If your watershed is between two weather stations, or if you're running a larger watershed, then this option will take into consideration orographic differences in precipitation and temperature and will better represent the weather within your watershed. But this option will only alter the precipitation and the temperature, while all the other weather parameters will still be stochastically generated from the selected weather station. For the Prism modified option, you can generate either one single weather file for the whole watershed, or you can generate different weather files for each hill slope. The next two options, observed DAYMET and observed gridMET, are similar gridded datasets, except they contain values of precipitation and temperature interpolated from various weather stations. We are still offering users options to revise the daily precipitation and temperature with the monthly and annually Prism maps, because the Prism maps have a greater pixel resolution of 800 meters compared to the more coarse 1 kilometer resolution for DAYMET and 4 kilometer resolution for gridMET. If you select the DAYMET and gridMET options, the model will take longer to build the weather files, so we mainly recommend these options if you want to compare model results of streamflow and sediment yield to observed data. Again, you have the option to select one single climate for the watershed or one climate per hill slope, and you can also select a starting and an ending date for the simulation. Usually the model will run for the number of years you are defining in the weather files. The future climate option allows users to build weather files based on future climate scenarios. Here we are using the precipitation, minimum and maximum temperature downscaled from 20 global climate models using the multivariate adapted constructed analogs, or MACA, statistical method. The MACA approach is also using the historic gridMET datasets for training. So if you want to compare future climate simulations to historic simulations, then for the historic simulations, you would also use the gridMET datasets. The single storm option allows users to run simulations with a designed storm. The user must enter the date of the storm, amount, duration, time to peak intensity, and the maximum intensity. If you're running simulations with a single storm option, also consider the antecedent soil saturation from the soil options. For example, if you want to model a specific storm that happened after several days of consecutive rain, it's likely that the soils are saturated, so you might want to increase the initial soil saturation. Otherwise, for a single storm event, water might end up infiltrating in the soil profile without generating any runoff. As an exercise, let's select the fastest and simplest method, the CLIGEN option, and build a climate file for 20 years. This option, like I mentioned, is relatively fast, and once it's complete, you can see a summary for the statistically generated weather file. In this case, CLIGEN built a file with an annual average precipitation of 1,300 millimeters, which is close to the annual average precipitation recorded at the Silver Creek Falls station. But let's now see what will happen if we select the PRISM modified. In this case, the PRISM revisions increase the annual precipitation to 2,400 millimeters. This is quite a big gap between the precipitation amount at the station and the PRISM adjusted precipitation amount. In this case, we might want to select a different weather station, maybe start with a multi-factor ranking and rebuilding the climate files to make sure all the additional weather parameters are appropriate for the area. This wraps up the climates. In the next video, we will run the model and look at the results.